So welcome ladies and gentlemen. This time it's a new setup because I'm not going live. The first video was a live, you can see it's already in my previous streams. But this time I will record it. I won't post-process or edit it. But still, I think it will be a little... I think it will be a tiny bit better. So, what can you see? And if you didn't missed the previous video, I'm following this path, which is called iExpert Roadmap. This, I think, is one of the best, if not the best, available on the web. So it will be an entire series. We will be trying to learn together to become a professional at AI. To be fair, I'm already a really good user, and I know a tiny bit. I know a lot about AI, in fact. But I'm an engineer. I've been for a really short period of time a data analyst. But you know what? Time goes on, and I am worse and worse every day in mathematics, in analysis, in many things. So we'll try to learn together for this roadmap. We will start with some basics, some fundamentals. I'm starting by that. So if you're an engineer, it will be easy. If you're not, hey, stick with our videos. It will be great. Then, here, if you're an engineer but not a data analyst, this one, exploratory data analysis, it's already good for you. Then, two paths. The first one, data scientists. Here, I want to do it because it's really interesting to learn. There are many links, in fact. That's the word points of this website, of this mind map. Really good. Then, I don't know many things in here. Well, I know some because of my studies, but yeah, not the best in this path. This one I know tiny bits, but some algorithm. I won't lie to you, I'm not the best either, but I know enough to help you understand also. Then we will dive into deep learning, which is I know about neural networks, and I know nothing except for needs. I know barely nothing here, except short term, long term also. Maybe it's not. No, it's maybe different. It's maybe different. Yeah, I don't know anything here, so it will be brand new for me. And data engineer, I don't know anything here. Big data, I'm same. So, all in all, what do I mean? We learn a lot. And with this strong foundation, we'll be able to understand GPT and large learning models more. There are lots. There is one of... Oh. There is one small... You can see on 2018 the first true language learning model with GPT-1, then 2019 GPT-2, and yeah, the explosion with GPT-3 around 2021. It was really the beginning. In fact, when I began working on AI a lot, it was early 2022, and I was one of the first, so in France at least. So I think, yeah, if you start now, you're still good enough, and you'll be one of the first. Ask the people around you, and ask them who are really using. I'm not even talking about understanding ChatGPT, but who is really good at using ChatGPT. Who use it already, and that's maybe 10% of the population of your knowledge, even if you're an engineer, for example. It would be far less if you're not. And then ask them a second question: what do you do on ChatGPT? Usually they just ask some small questions. They're just using that to generate text or something. You can do much more than only this. But to understand how to use it, I think it's important to understand how it works on the inside. So, On the first video, we were talking about mathematics. We saw a lot about vectors, what is a vector, what the notation of a vector, and we talked about dimensions. So all in all, a vector is a magnitude and a direction. A vector, yeah, there is no set point, no origin. Negative vectors do exist, and in coordinates spaces, you can be a 2D vectors as you are here. You can be a 3D vector here. Yeah, here I think no, it's already 2D. Yeah, but you can be also a 3D vector. It's easy to represent in your mind, 2D or 3D, but it can be much more than that, and then it's really hard to explain it. We can, yeah, plot maybe 10 dimensions on a 2D plot or 3D plot, but in fact, you can't really represent it. And as I said, there are much more dimensions, and I think it's around 1496 or 1596 dimensions for ChatGPT. So that's a really precise vector if you want to know. And that's why words, he understands words because of their vigility, you know. So here, let's continue. Sorry, I digress a lot. So now we are looking at this video, how to add vectors. Let's see. Let's put some subtitles and see. So, two vectors have two components. What can we do on the operation? It's easy. If we want to sum vectors, I will display it, sorry. If you want to sum vector A and yeah, it's useless to write it, and vector W, its usual notation, you can just do sum of the coordinates of V and W of the coordinates. I don't need to. So here it is. Really easy. I don't think it's really something new for you. Let's just make something like this. I just wrote an example. You can see it here. Here it is. Tell me about the setup, if you like it or not. It's, yeah, maybe not optimized. I'm writing on my iPad and showing you the most in real time that I can. So, what is it saying? Sorry. The sum of a vector. Yes, so we can draw it. So for example, we have something like this, 2, 0, so it will be something like this, and 1, 3, which will be maybe like this, and the sum, it's like this. If you want to sum two vectors, you need to add them one after each other, and it creates the new vector, which is this one. But it's not this video. Yeah, I'm sorry. You will find many tutors on the internet. I'm just okay. We know about that. If it's about mathematics and basic mathematics at that, let's just keep it. You know, there's plenty of video. It's I think around high school level, so you can do it. You can find a lot of materials about it. Let's see what the name. Multiply a vector by a scalar. I will show you the video at the left, but let's just be fast on this also. Here it's for the addition. If you want the multiplication by a scalar, it's just a number like 2, 3, or 4, or that can be multiplied to a vector. That's the definition of a scalar. So for example, you have 2, 0, and you want to multiply by 4. It's easy. You just multiply the coordinates. So you get 8, 0. There it is. You can see it on the video. So it's just a bigger vector, or or in the opposite side. So can change. I don't know if it's the exact word. The orientation, not really. The cannot change the direction. You know, I mean, the vector can be bigger, can be in the other side. I don't know if it's side, you know. The arrow, I mean, can be pointing towards here or here. But no matter what, no matter if it's this or longer or in the other side, it's still on the same direction. Same line, if you want. So here it is. Next video. Some examples. I mean, we don't really care about that. You can watch the video later on. Exercise, we don't really care. I mean, what can we do about that? Scalar multiplication, let's see. It's an exercise, we don't care. Unit vectors. Okay, what can we say about unit vectors? For example, unit vectors are really useful for coordinates. When you are plotting something like x, y, usually you're using two vectors, the one which is x, the other which is y, and they're called units. I don't know if it's the exact. Maybe I'm mistaking something because of the translation. But usually, unit vector, I think it's something about the length of. I think it's something related to the length being 1. So, which is really useful because if you have a length of 1, you already know that this vector projection is equal to 1. Then if this one go further, it's more than 1, and you can make many calculus related to that. But maybe I'm wrong. Maybe I'm really wrong about that, and the translation is maybe not good. So let's see. No, I'm right. Okay, yeah, 1, 0, and yeah, and now we can just say that a vector and express it based on the other. I won't make a long video about that. It's really interesting. In fact, if you're learning physics for the first time, try to learn first what is a unit vector, and most likely how it is used as a landmark, you know, in a coordinate system. When you're creating a coordinate system, as I said, it's made of those unit vectors, and they are really useful because you can express, for example, your vector as a projection on x and just say it's x, and yeah, really useful. For example, this vector, let's say, make this vector which is, let's call it another v is equal to 2x. I forgot the vector, of course, on xy, but that's really useful, and you will see a lot in physics. So here it is. You can see at the same time, I guess, the video, the subtitles, and the video at the left. So you've got my voice plus this video from Khan Academy, which is a really good resources. Let's see what's next. Let's continue. Unit vectors, no. Parametric representations of lines. Let's see, and let's skip maximum. Oh, this one is big. The only problem I've got here, to be fair, it's I don't really know uh, what's the name of those notions in English. So I'm not really sure I've done it, but what is the exact equivalent? So let's see. Let's see. Let's see what this video is about, and we will stop here for today. I tried to explain as much as I could, and I think once you know about vectors, you will be able to understand the next principles, and also you will be able to understand how GPT works. As I told you in the first video, but you weren't there, GPT is about proximity, and for that it's often using for vector stores cosine proximity, which is really easy. It's just a cosine between two words plus the normalization. The norm. I forgot. Sorry, forgot the word. You know what's the intensity? It's called a magnitude. Magnitude of a vector, of course. Sorry, really sorry. So, what is he saying in the video? Let's focus on the video a tiny bit. A set is defining a set. To multiply some scalar times C is a member of the real numbers. Okay. Why not? Okay. C can be 1, 1.5, 1.7. Okay. Yeah, C could also be 2, for example. What's happening? 2V, as we saw previously, it's only the projection, so same line. Yeah, it could be like this. So I already told you, you can change the side and the magnitude, but you cannot change the direction. I will also add side plus magnitude. But you cannot change the direction of the vector with only a multiplication by a scalar. So, we can change the side. So we have a line, as I told you previously already. I told you that around here, but you couldn't see it. I'm really sorry. Side plus magnitude. I will dezoom and zoom a little bit so you can see it. Here it is. So I told you already previously, but you didn't see it. I'm really sorry because I'm sometimes writing on my iPad and you can see it directly on my computer. It's not the best setup. I should do something different. I'm using the cheapest iPad also, so maybe I could do something better later on. But, okay. What is he saying? He is saying that the vector can be drawn anywhere. So, more or less, he is saying that instead of having just this line, you can also be having this line and this line. Because if you multiply a vector by a scalar, it will... A vector, remember in the first video we say that a vector can be moved everywhere. Vector can be there, there, or there. There's no origin. But a vector can also be multiplied by a scalar, so it's a line, but a line that can be moved anywhere, so we can have as many parallel lines as we want. So yeah, it's kind of a slope. Yeah, why not? It could be represented maybe. Let's see what he's saying. I don't know. Honestly, I don't really know what it is about. X, okay. Let's see. I want to represent this line. Is drawing a parallel line, okay. Okay. So as I said, it could be the same vector, but drawn anywhere, but it's the same. Oh, maybe you can express it with a function. Just a simple... I forgot the name of the function. I'm sorry, because I'm mixing the languages. It's hard, and when I'm mixing it, I can't find it even in my native languages. Okay. I'm wondering what is all of that about. Okay, so yeah, it's kind of saying about the translation of a vector. Like, you've got your vector here, but you want to move it, so you draw a line here. This vector can be moved thanks to another vector, in fact. In fact, a vector, let's say at the same time, you can read from the left if you don't want to hear me. And let's say you shoot a ball here. You're pro at baseball. You got your glove here, your small head, and you're trying to launch the ball as far as you can. Here you represent a motion by a vector. So this ball move from this origin to end here with maybe a vector going down. So you move from one origin to another origin. Let's say you hit a wall. Your ball was there, it hit the wall here, and it's going down. So you've got this origin here, and this origin here. Maybe you can take the wall as the coordinate. So what would we do here? What did we do? We used a vector. We drew a vector to describe a motion. That's what it used. Vector describe motion. It's really useful. It's not only used for that, but it's really useful. So by having our vector here, we can describe a motion of our vector. We want to move it here, and for that we can draw another vector which represents the motion. It's a bit complicated, but in fact it makes sense. Then let's say you have another vector here on the same line, and you want to move it by the exact same length. You're using the same vector. This one you're reusing it, and you'll get the same here. So yeah, we can use a vector to do a translation from this origin to this origin. So it's called a translation. Like this ball is translating to the right, which is described by this vector. This vector is translating to the north, let's say, which is defined by this vector. Here we are. So yeah, he drew a function, which was going to be expected. You can draw a function. And in fact, the only thing that is changing is not m, it's b in the function here. I didn't listen to the video, but I think he told you that at the same time. We could read the subtitles. Too long. We could copy the subtitles and paste it to GPTs if we want, but let's not do that. You know, you saw the video and it's really basic. It's really basic. Let's see. B. It's done in r squared, which is logical because there are two coordinates. So a single number, a single real number would be r1. Here it's r2 because it's two coordinates, 2 and 1 for A and 0 and 3 for B. If we were in 3D, it would be r3 because 3 coordinates. It was already said in the previous video. We could draw a line here. Yeah, why not? So we could define a line based on the ending points of two vectors. Yeah, so for example, we have, let's say, a proper example, two vectors representing another line. Why we will do that? Let's say you have x and y, your coordinates. You use the gun, for example. Sorry about the analogy, not the best. And you shoot a bullet. And this bullet, it goes there, 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 and you killed someone. Yeah, not really good. From you started here, you were at this time, let's say it's time here, t equals 0, t equals 10, for example, I don't care. So you have two vectors and you're using the two ending points of the vector to determine the position. So your coordinates, it's a strange, let's say you used, I don't know, how it's called. Let's say you used the witness here, there is a witness, is considered as the setting points of the coordinates, which is a really strange thing to do, but why not? And you've got two vectors and a straight line going in. And in this case, you see the function. Sorry. What did I miss? It transposed the vector. Okay, so a transposition. Maybe you did it on Excel without knowing it. You know, on Excel, you can paste something like this with a T, I think, when you passed some cells. And instead of having 1, 0, 0, 1 on a line, when you passed it with Excel, you get 1, 0, 0, 1 in any cells. So transposition is kind of the same. Here we had two vectors, one like this, one like this. And with the transposition, instead of having the vector like this, you get a vector like this. And instead of having your vector like toward the north, you got something toward the east. So that's a transposition. I'm sorry about my notes taking, it's not really good. Transposition. Here you have your transposition. So, how do we calculate the transposition? It's just basic calculus done on the vectors. So what it is saying is instead of having b minus 1, let's say what it is. Instead of having 1 and 2 in this side. Oh, whoa, I don't really get what it did. We have 2. Oh yeah, that's it. We have minus 2. Okay. It just did a subtraction. Maybe not a transposition, in fact. It's just a subtraction of two vectors. No, it's not hard. I won't say it's hard, but I didn't listen enough. X and Y coordinates. You know what? Sorry about it.
1 minus P2.
Let's pass it to ChatGPT. I've got my own app for this. Oh no, it's not the right folder. Let's say this one. I think it's this one. Let's paste it. And mathematics. Get oh cool. No, there's no transcript. Why is there no transcripts? Subtitles are no, they're not. It's because of this. Okay, let's pass it to ChatGPT because I'm too tired tonight and I'm waking up really early tomorrow. So let's just pass it and see what it's saying. Why is it in Russian? It just retrieved. It just retrieved in Russian. Why not? I mean, why not? Why not? English and mathematics. Get transcripts. I'm wondering if it's the right video, so let's just copy paste just to be sure. It's the right one. I think. Copy chunk. I'm sorry if I'm not really faster. I try. I swear I'm trying at least. Not really good, but I'm trying. Let's see. Oh, still in Russian. It's because my app is getting the main subtitles, which seems to be Russian, which is a bit weird. So let's see what the video is saying all in all. And let's see if we missed something. A vector in r squared. It's about, there's a direction, a magnitude, so there's a 2D space. That's why it's r squared. Because there's two real numbers on a plane, like x-axis and y-axis. That's it. We know. Plotting a vector, no problem. Scalar multiplication, we saw it together. No problem, in fact, about that. Scale the vector magnitude without changing its direction. That's a better name. Okay, when you use a scalar, you multiply the coordinates, each coordinates by the scalar. If it's a vector with 5 dimensions, you multiply the 5 dimensions. Collinear vectors. Oh, that's what he was explaining. Oh, I forgot about it since high school. Yeah, two vectors on the same line on parallel lines. So every vectors here are collinear. Every vectors here, which are the same but put on different origins, are collinear. It's an important thing to remember. Representing lines using vectors, a line can be represented as a set of positions vector. For example, line L can be defined as x plus t v. X is a position vector, v is a direction vector, and t is a scalar. So what is it saying? X is the position here along the line. No, x is the position on the x-axis. On the x-axis, sorry. So x is here. For example, let's say I will show you another example. Let's say you have another plane. Let's pick one. You have your plane here. So x-axis is here. You start from there, which is x here. So here you start from there. Plus position vector. So x is also a vector, so it could be something like this. Start here. You have t is a scalar and v is a direction vector. Here you've got x. Yeah, there are two x's, but let's not call it x. Let's call it e, for example. So we have x here, which is a vector also, which is like the origin. We have a direction vector, could be something like this, for example. It's t. And we have, no, it's v, sorry. It's v, the direction vector. And we have t, which is the scalar. So with the scalar, for example, scalar is 2 times v, is 2. And it will be something like this. And here is t. V is just defining the direction. So all in all, we've got a line only with those 3 information. And that's why we told earlier about the translation and the direction vector. Let's see. So at the end, he was speaking about the 3D spaces. It's the same thing. In fact, it's just in 3D, but it's really, I won't lie to you, it's the same. It's really useless. I won't say it's useless. It's really important, but it's the same at the end of the day. No, it's not. No, it's not 3D here. Yeah, I give up. So, you've got the vector representation. It's just x, y, z. It's not only x, y. Now there's a z. We can plot it. It's always easy for 2 dimensions and 3 dimensions. We can, but for all of the other dimensions we can't. So let's say we've got this vector. Let's put 1. In fact, let's say we've got this vector here. So we count 1, and this one is not really deep, so it's 0. Let's count this vector. It's along x 0, along y -1, and along z it could be 2, for example. So here we have plotted 1, 1, 0. Sorry. And 0, -1, 2. It's not the best representation, but still. What other thing did you mention? Parametric equation. Oh, it's been an awful long time. A line can be represented by parametric equation. As we told you previously, a line is just an origin, a direction, and a vector. Okay, it's the same thing really. Let's just show you the video, but it's really the same thing. Where is it? Let's make up some numbers. It's not the best video for explaining this. It's just additioning some numbers. So we have here, we have something like this. -1 plus -1t. X equal -1 plus -1t. Let's say we are here. T is okay. It's not the best video about this. Really, it's not. You know what? Next time we talk about parametric equation. It's something really important, let's say. And see you next time. Bye.